All right, yesterday we talked about domain and range. Domain is what values? X. Range is Y, okay. And then intervals of increase, decrease, constant, where the graph's going up, where it's going down, where it's staying flat. And where do we read that? On what axis? The X, okay. I'm going to post some extra practice. Like I said, Mr. Saldana put it together for all of 2.3. It's probably a good idea for you to look at, go over, but it won't do as an assignment. Two other things we want to talk about today is if a function is even or odd, and how to find the zeros. Okay, so there's two ways that you can determine or talk about a function being even or not. You can talk about it graphically by looking at a picture, or you can talk about it algebraically. So first, let's talk about it graphically. I'm going to give you some notes here. Write this down. Graphically, thank you. All right, graphically, if a function is even or odd, all right, I'm going to write even over here and odd over here. If you have a picture of a graph and it is even, two things will happen. One, both arrows are going to go in the same direction. And has to be both things. It has to be symmetric to the y-axis. What does that mean? What does that mean if it's symmetric to the y-axis? The y-axis cuts in half, right? So if a function is even, the direction of the arrows is the same. They're either both going up, they're both going down, and it has to be symmetric to the y-axis. If a function is odd, what do you think the directions of the arrows are? Opposite, yep. Opposite directions. Think about odd, opposite. Opposite direction. And two things have to be true. It has to be symmetric to the origin. How can you tell that by looking at it? It goes through the origin. All right, so graphically, if you have a picture and it says, is this function odd, even, or neither? All right, so I'll draw some pictures. So here's my X and Y axis. I'll do a picture in green. Pretend that's the best, most perfectly drawn thing you've ever seen. We'll do one in yellow. I'll do one in pink. And then I have a pretty blue. We'll do blue. All right, do you see those four different colors? All right. So again, let's pretend the green one is perfectly drawn on the left-hand side and right-hand side. So we're looking at the green, all right? We're going to talk about green right here. This function right here. Is this odd, even, or neither? First thing you look at, guys, the direction of the arrows. What is the direction of these arrows? Same or opposite? Same. They're both going down, right? So this could be an even function. What would the other thing have to happen? The y-axis does what? What does the y-axis have to do? Symmetric to the y means that the y-axis cuts it in half. If that was drawn perfectly, does that look like the y-axis cuts it in half? It's a mirror image on one side and the other. Yes, so you would say that's an even function. All right, so let's look at yellow. First thing we do to determine odd, even, neither, you look at the ends of the graph. Look at the ends. Are they going in the same direction or opposite? Opposite. So it could be odd. What's the other thing that has to happen in order for this to be odd? Has to go through 0, 0. Does it? Yeah, so what is my yellow function? It's odd, okay? So now let's look at pink. Look at the direction of the arrows. Same or opposite? Same. So it could be even. But what's the second thing that has to happen? The y-axis has to cut it in half, does it? No. So this you would say is neither. It's neither odd nor even. God bless you. And then let's look at blue. Look at the ends of this arrow here and here. Same or opposite? Opposite. All right. So what's the other thing that has to happen in order for it to be odd? Through 0, 0, through the origin. Does it? No. So this one is neither. All right. You probably won't see a bunch of odd, even, neither with graphs. How you're going to see them is algebraically. All right, this is algebraically. I know you guys look at this and you go, what? I understand that. I'm going to show you what this is saying, and then I'm going to show you a shortcut on how to tell, and it's going to, I think, make things a little easier for you. So, if you are given an equation, it says determine if the function is even, odd, or neither. Okay, what that last slide was telling you, just watch. You don't have to write this down. They want you to plug in negative x, right? Right now, we have positive x in there. They want you to plug in negative x. So if I were to plug in negative x and evaluate it, negative x cubed gives me negative x cubed. And then minus a negative gives me what? Plus. Then you compare the original function to the one that you just evaluated. What's the highest exponent you see? 3. What kind of a number is 3? Odd or neither? I'm sorry, odd or even. It's odd. So this could possibly be an odd function, or it could possibly be a neither function. When you compare these two, are they exact opposites of each other? Well, let's look at this. My first term here is negative x cubed. This one is positive x cubed. Are those opposite of each other? Yes. The second term is positive x. This one is negative x. Are they opposite of each other? Yes. So then you would say, oh, algebraically, this is an odd function. I find that to be very confusing. I think it can be very confusing to plug in a negative x. So the shortcut is you pick any number bigger than 1. And the exact opposite. If you want to use 2 and negative 2 every single time you can. If you want to use 3 and negative 3 every single time you can. You just pick any number you want and its exact opposite. You can determine the exact same thing. I think that's the best way to go about it, so that's how we're going to do it. So this is what I want you guys to do on all these problems for even, odd, or neither. First thing you do is identify the exponent. What's the highest exponent you see? 3. So your only two options are this could be odd or it could be neither. It cannot be an even function if the highest exponent is an odd number. So now I want you to think about the directions of the arrows, right? Set this up. It looks like this. Graphically, in an odd function, do the arrows go in the same direction or opposite? Opposite, right? So I want you to write opposite right here in between those two. When you plug in any number bigger than 1 and its exact opposite, let's watch what happens here. I'm going to plug in 2. Somebody do negative and positive 3. I'm going to plug in positive 2 and negative 2. So when I evaluate this, watch, I have 2 cubed minus 2. And then here I have negative 2 cubed minus negative 2. So on the left-hand side, when I evaluate, what is 2 cubed? 8. And then what's 8 minus 2? 6, okay? On the right-hand side, what is negative 2 cubed? Negative 8. And then I have minus a negative 2 is what? Plus 2. What's negative 8 plus 2? Negative 6. Are 6 and negative 6 opposite of each other? Exact opposites? Yes. So this is an odd function. It doesn't necessarily matter what the answers are. It's the relationship to each other. If you plugged in 3 and negative 3, anybody do 3 and negative 3? Let's do it real quick. What's 3 cubed? 27 minus 3. 24. What is negative 3 cubed? Negative 27 plus 3. Negative 24. Those are exact opposites of each other. You could do 2 and negative 2 every single time and it would work. But if you were to evaluate that and you came out with 6 and then positive or negative 4 or something like that, they're not exact opposites, so you would say neither. So let's look at the next one. Identify the highest exponent you see. 2, okay? Squared. What kind of a number is 2? Even. So my two choices are either even or neither, all right? So let's get our little problem set up here. A little squiggly line in the middle. I got 2 answer choices, 2 boxes. Think about the directions of the arrows in an even function. Do they go opposite or do they go the same? Look back at all the notes I just wrote, guys. If you have an even function, do the directions of the arrows go the same direction or they go in opposite directions? The same. So write the word same here. So I'm going to evaluate using positive 2 and negative 2. Any number and its exact opposite. Somebody do 3. So when I plug this in, I have 2 squared plus 1. And over here I have negative 2 squared plus 1. What is 2 squared? 4. And 4 plus 1 is 5. What is negative 2 squared? 4. And 4 plus 1 is 5. Is 5 the same as 5? So what did you just prove? This is an even function. You can't just look at it and say it's even or odd. If you guys did 3, let's do 3 real quick, everybody. What is 3 squared? Plus 1, 10. What is negative 3 squared? 9 plus 1, 10. Is 10 the same as 10? That's how that works. All right, let's look at this one. What's the highest exponent you see? 1. All right, what kind of a number is 1? So this is either an odd function or a what? Or a neither, however you want to say it. So think about what this looks like. What are my arrows going to be? Same or opposite? If it's an odd function, opposite, odd, opposite. So plug in 2 and negative 2, 3 and negative 3, 4 and negative 4. Does not matter. Any number bigger than 1 and its exact opposite. So I'm going to say 5 minus 3 times 2. And over here, I'm going to say 5 minus 3 times negative 2. Well, what's negative 3 times 2? Guys, negative 3 times 2. Negative 6. So this is 5 minus 6. What's 5 minus 6? Negative 1. Okay. Over here, what's negative 3 times negative 2? Positive 6. So 5 plus 6 is 11. Are those two numbers exact opposites of each other? No. So what's your answer here? Neither or neither. Perfect. Does that make sense? If you think the function is even, because the highest exponent is an even number, you can evaluate using 2, negative 2, 3, negative 3, 4, negative 4. Your answers will be the same. If the highest exponent is odd, you can evaluate using 2, negative 2, 3, negative 3, 4, negative 4. Your answers will be exact opposites of each other. If neither of those things happen, it's neither. Yes? All right. Zeros of a function. I want you to write this down, guys. Zeros. Solutions. Roots. X-intercepts. Those all are the same thing. Zeros, solutions, roots, x-intercepts. What that means is set the equation equal to 0 and solve. We're going to get to some things 90% of the time you're going to factor. But you're finding the solutions, where the graph crosses the x-axis, what x equals. So we got 3 little examples, then we're done. Find the zeros. What does that mean they want you to do? Plug in 0 for what? For x. So I'm going to plug in for f of x. You're going to set your equation equal to 0 and solve. So I have 2x squared minus 3x plus 1 equals 0. What kind of an equation is this? If I have x squared, what is it? Quadratic. It's a quadratic. So you have 3 options on how to solve this. You could try to factor it. You can use the quadratic formula, or you can complete the square. Do you guys want to try to factor? All right, let's see if this one factors. Can I multiply 2 times 1? What are the factors of 2 that multiply to give me 2 and add to give me negative 3? So x minus 2 and x minus 1. If you're going to use my trick, guys, what do you have to remember to do? Divide both terms by the a. So divide this by 2 and divide this by 2. So we have x minus 1 and 2x minus 1, both equal to 0. So now I take each piece and I set it equal to 0. X minus 1 equals 0. 2x minus 1 equals 0. I'm going to add 1 to both sides. So here, x equals 1. Here, I'm going to add 1 to both sides. 2x equals 1. Divide by 2. So x equals 1/2. Anytime it says to find the zeros, the solutions, the roots, the x-intercepts, all that means is set your equation equal to 0 and solve it. So, just the only other one we have? Okay. I'm going to set my equation equal to 0 and solve, yes? Okay, so I'm going to plug in 0 right here and solve it. So I have 0 over 1. How do I get rid of a denominator? How can I solve this equation? Not so much the conjugate, but if there was just a 3 on the bottom, what would you multiply the entire equation by? 3. So since there's an x plus 5 on the bottom, can I just multiply the top over here by x plus 5 and the top over here by x plus 5? Sure. What you do to one side of an equation, you can do to the other. So when I have an x plus 5 on the top and 1 on the bottom, what do? They cancel. And then what's x plus 5 times 0? 0. So you just end up with 2x plus 5 equals 0. What are the two things you have to do to solve that? You're going to subtract 5. Good. So 2x equals negative 5. And then what? Divide it by 2. So x equals negative 5 over 2. How could I tell from the very beginning for number 12 that I was going to have 2 answers, and for number 13 I was only going to have 1? Highest exponent you see in number 12 is 2. What's the highest exponent you see in number 13? 1. Little trick, guys. Anytime you have a denominator, like a fraction like this, or rationally ask for the zeros, all you have to do is set the numerator equal to 0. But if you don't see that, no big deal. Just multiply both sides by the denominator and it'll cancel. All right, that's it. So what I want you guys to do, you have web assigned that's due in the morning that you can work on. I'm also going to post the extra practice that you guys can work on tomorrow in class. Ask me some questions, and then Mr. Saldana is going to come up with a review. So you have your quiz on Friday, and it's over section 2.3. It's going to be domain, range, intervals of increase, decrease, constant. It's going to be odd, even, neither functions, and it's going to be finding the zero. So it's a lot of stuff in one section. You need to make sure the next couple of days that you guys are practicing.